Hello, everybody. My name is Serdar Semih Coşkun. I am an assistant professor of operations management at Istanbul University, Faculty of Economics, Department of Business Administration. First of all, I would like to say thank you for having this conference and giving me the opportunity to present my study to that elite community. Actually, this study is a published one exploring the Gaussian investor sentiment process. It has recently been published in Borsa Istanbul Reviews, which is an Elsevier journal. Here is my agenda. I'll briefly touch the introduction and mention about the theoretical background and motivation. Then I will elaborate on the methodology. Then I will report the results and discussion, and we will make some concluding remarks. As the traditional capital market theories tries to find out a competitive equilibrium between supply and demand, and there it tries to explain how the price volatilities occurs at the capital markets, like stock markets. And these theories basically assume that markets must be efficient. That means, first of all, the signals investors receive from the environment must be efficient, and they contain each information regarding the asset values and fundamentals. And this is known as the efficient market hypothesis. It is very famous for the traditional finance researchers. And also, based on this efficiency, investors will be rational economic agents, and they try to maximize their utility by making decisions and picking the most valuable option among the investment opportunities. At this point, sentiment will randomly deviate. Sentiment means the emotions that people behaves in their this decision-making process. And people actually learn sentiment throughout their life cycle and lifelong experiences. And the traditional psychology theories like social learning and classical conditioning and operant conditioning explains how people learn throughout their lifelong experiences. And based on that, the efficient market hypothesis assumes that we can overlook the sentiment fact. However, the recent discoveries in the cognitive science and behavioral finance showed that the story is a little bit different from that. First of all, signals are not efficient because environment involves many types of uncertainties. And even if signals, let's say, make it inefficient, people cannot use all the information because of their limited cognitive capacity. So signals might be inefficient, and investors might be irrational to some extent in their various conditions. And at that point, investors use cognitive heuristics to compensate with the environmental uncertainties. And therefore, the heuristics are such kind of tools that decision makers use for making fast decisions and reduce the uncertainty. But these situations create systematic errors in the price fluctuations in capital markets, because these systematic errors coming from the cognitive heuristics are actually based on the evolutionary roots rather than emotions that learned by the long experiences. It is very interesting and an important critical point to differentiate these two approaches. Therefore, the question is, how can we explore the effect of cognitive heuristics in investment decisions? This is the main research question of behavioral finance. And if we can manipulate the signal efficiency, we can reveal the effect of those heuristics. And Therefore, we need a controlled environment and create some uncertainty. In this study, I am going to develop the GISPEP framework, and we use the Bayesian network model for manipulating the signal efficiency and provide some imperfect information to the decision makers. Then we will use and train a Gaussian process regression model, which is another Bayesian tool, and explore the investor sentiment. That is the sentiment functions, which shows how people behave against the uncertainty. Here you see the GISPEP framework. It consists of 3 stages and 8 steps. It starts with developing the hypothesis based on the prospect theory. Then we collect data from Borsa Istanbul stock market and Turkish Super Football League. So our empirical case is from the football industry, because football stocks are very speculative and open to sentiment facts, and people's stocks have little fundamentals, but rather some intangible values such as the brand value. We assume that football industry is a perfect place to judge the effect of heuristics. Also, the football outcomes are quite objective, like when a team wins a game, it receives 3 points or 0 points in a defeat situation. So these rewards are quite objective, so that we can compare our subjective values later on. In the setting the research model stage, we developed a causal network using the Bayes network and evaluate those field signals received from the football fields and see how these results turns out the value in the stock markets as return rates. Then we explore the sentiment using sample from data points and sample that we draw from the sentiment functions. And it's actually an artificial data rather than a real world data, because we add some imperfect information to create uncertainty in a controlled manner. And then we use these artificial sampling to train the Gaussian process, and then we obtain 4 different sentiment functions based on the competitiveness facts and the signal type. Then we use the cubic library divergence tests to evaluate the difference between those functions and and decide if our hypotheses are valid or supported in our case study. At the end, we discuss the results based on the past literature. And for our research model, we use the PyMC3 library, which is a probabilistic programming approach written in Python. So we wrote our codes using PyMC3 library in Python. So in our background, we relied upon the prospect theory, and that theory primarily suggests that the value function need to be redesigned based on gains and losses, as well as the value on the vertical axis. The value function might differ according to the sides where you are standing on. The steepness of the function changes, as well as you see, as well as people assign more value to the losing events rather than winning events. And this is the main assumption of hypothetical value function of prospect theory. In this sense, we set 4 research hypotheses. H1 is field signals influence the value that investors place on the relevant stocks. It actually refers to the representativeness heuristics. Representativeness refers to that people overweight the likelihood variables, whereas underweight the prior variables. Representativeness means the violation of Bayes' rule, in short. Therefore, field signals will be likelihood variables of our sphere. H2, when competition is weak, investors losing signals. It actually searched for the existence of availability heuristic. And availability has an opposite characteristics with representativeness. And because it also a violation of Bayes' rule, but at this time, people overweight the prior information and underrate the likelihood variable in a Bayesian model. H3, when competition is strong, investors attach more value to losing signals than winning signals. It is actually the most famous hypothesis of the behavioral finance, loss aversion, and it is a well-studied phenomenon. And once again, here we test the existence of this hypothesis. H4, when competition increases, investors become more sensitive to field signals. And this hypothesis actually tests the regulatory role of competitive emotion. Across the seasons, we are going to see if competitiveness play any role. On the right-hand side, you are seeing the directed acyclic graph, the graphical model of our Bayesian network. There are 7 different random variables. The events and meaning of these events, such as we have here losing, drawing, and winning outcomes of match results, like M variable. Although we took the drawing events, since it does not make any sense in our case, we just use losing and winning outcomes to evaluate these effects, And the season variable is weak and strong competition. You are going to see how it happens. Then it is R variable, that stock return decreases or increases. Here, you find the joint probability distribution of our variable sets and the conditional probability and of our Bayes theorem. Based on the Bayes theorem, we calculate the inverse probability. Here, the match results and seasons are the likelihood variables, whereas the return rates will be the prior variable, and we infer the posterior values of R variables using this equation. In order to add some uncertainty to the signal, we redesigned the signals using hyperparameters that we defined. And as I mentioned earlier, we drove samples from the Bayes networks so that we use probabilistic field signals to provide imperfect informations to the decision makers. Here, I'm showing how we got the X and Y couples and paired couples that we use to train the Gaussian process regression later on. So let's switch to results and discussion. Here, we are seeing the descriptive statistics. And in our sample, there are 3 Turkish football clubs, Galatasaray, Fenerbahçe, and Beşiktaş, and their performance from the 2021 season and 1920 season. On the right-hand side of the graph, as you see, these teams present a less competitive performance, whereas on the left-hand side, they performed a more greater performance. They become much more competitive in their seasons. And actually, these two seasons provide us to carry out a natural experiment, because these performance make group into two different competition level, and there is statistically significant difference between the total scores of these seasons over these groups. So it's allow us to use these groups to define the competitiveness facts. Here we are seeing the signal processing results that we draw from the Bayesian network analysis. And here the return rates, the prior probabilities of return rates are on this row. For example, the decrease of return rates that the Galatasaray has in any season is 0.45. So this is the probability of the return rate decreases in any time, in any day. It's a prior knowledge that we get this knowledge from the Bayes network analysis. Then we add some evidence to this prior knowledge and see how the probability changes. For example, when we add the information that Galatasaray lose the game, the probability of decrease climbed to 0.59. And another step, if this situation happens in a strong competition, this probability also climbs to 0.68 levels. We can check this pattern for each club, and we will see that this situation is valid for each club. Therefore, we can calculate the geometrical means and make those results generalizable for further analysis. And here we are seeing the Gaussian process regression models and the results, summary tables of the Gaussian process regression and the simulation study. I passed the mathematical details of Gaussian process model. One can look up the paper for elaborating more on these details about the mathematics of the Gaussian process and our simulation process. But here I just jump to the results here. The Gaussian process regression has two parameters, the length parameter and the error parameter. And we explored four Gaussian process regression, which corresponds to relevant sentiment functions based on the outcomes and the seasons. On the right-hand side, we see the simulation process. The reliability and validity is sufficient. And we conducted a parallel chain approach for the simulation, and we draw 5,000 samples from the posterior distributions of our parameters in the inference process. And the reliability is perfect because the Gell-Mann-Rubin test assures that the reliability of the simulation is efficient. And here we are interpreting the length parameter as reflecting the homogeneity of market expectations here. Because the length means the bandwidth, or in other words, it is the bandwidth parameter, and it explains the uncertainty of the Gaussian bandwidth. So in theory, it refers to the market expectations. In classical finance, assume that market expectations must be homogeneous. However, here we observe that the expectation parameter changes according to a systematic pattern. For example, low signals increase little bits, increase the length parameter, as well as the season fact to increase this parameter, the value of this parameter. Here we are seeing the sentiment functions or sentiment functions. The graphs with black dots represents the winning events, as well as the maroon dots refers to losing events, the losing a game or matches. On the right-hand side, we see that the high competition is case. Investors attach higher value to the losing events than winning events. And it is understandable, and this finding supports the earlier findings in the finance literature because it refers to the existence of loss aversion. People become loss averse when the competition is high. And we must evaluate the difference between those two functions within the seasons using the Kubic-Leibler divergence test, as you will see later on. However, on the left-hand side, we see something interesting because people attach greater values to the winning events than losing events when the competition is low. The low competition means the favorite team lag behind the leader on the league table. So in that case, whenever teams win a game, people become to attach greater value and exaggerate these wins in weak competition. And actually, it refers to the existence of availability heuristics, because in that situation, people the competition fact and people forget the role of these teams on the league table, but exaggerate the winnings. It is understandable because our teams are the most famous football clubs in Turkey, and these clubs are known as the big threes. So people imagine the championship whenever their team wins a game. And this refers to the availability heuristics. And also, in addition to that, we compare the sentiment functions across the seasons and against the constant values. Here we are seeing the Kubic-Leibler divergence test results. D1 and D2 refers to the existence of representativeness, and this hypothesis has not been supported by our findings, because when we compare the sentiment functions against the constant value, the prior probability of increase and decrease of the return rates, we got the results below the 0.10, which is our decision criteria that we defined earlier for supporting an hypothesis. We conclude that representativeness is not the case in our empirical study. And below, you are seeing a piece of code, and I'm showing how I calculated the Kubic-Leibler scores. It is actually a mutual entropy between this data drawn from simulations and the constant value, which is 0.46. This value is the prior probability of decrease of the return rates. And we took this probability from the Bayesian network analysis. Also, the 54 is the prior probability of increase in any return rates of relevant both stocks. So we fill the number array with the same length of the simulation data and compare these NP values and obtain the Kolb-Leiber results. As I told you earlier, I also compared statistically compare the functions within seasons and between seasons, and therefore the availability, loss aversion, and regulatory role of competitive emotion have been supported by our case study, our empirical study. So let's come to the conclusion. First of all, literally we can say investors use availability in weak competition when they receive win signals, whereas they use loss aversion in strong competition when they receive loss signals. It sounds a little bit complicated, but it refers to that the competitive emotion regulates and moderates the asymmetrical rise of availability and loss aversion heuristics when we provide imperfect field information and uncertainty. So I guess this might be the first time we come out that there is an asymmetric balance between the cognitive heuristics, and it happens in a dynamic market structure, as we can see. And another point is our cognitive heuristics might be some behavioral systematic errors that influence the market equilibrium to some extent, just as the macroeconomic risks. The traditional finance theory only recognized the macroeconomic facts like inflation rates or interest rates to become the risk factors in the capital markets. However, our results show that the behavioral systematic errors can also be the case because people rise those errors from individual level to the market level thanks to their evolutionary roots. And another factor is the homogeneity of market expectations can be questionable because it has varied in our Gaussian process results. And the last point is the Bayesian hypothesis testing using the probabilistic programming languages might open a novel and very innovative avenue for testing research hypotheses in future studies. And the last point that I want to underline is that in our Gaussian process results, we saw that the length parameter perfectly imitate the market structure. In fact, we might expect that the investors get confused when they receive a loss signals if their teams is going to the championship in the league situation. So the homogeneity of market expectations might be questionable in that situation. However, truth be told, I have no idea why the Gaussian process and the Bayesian network combination of our model, how our model perfectly imitate the real world. It points the power of artificial intelligence, I believe, because not only individual level, these tools can imitate the market level behaviors of society. Thank you for listening to me. Thank you for your attention.